Hello all, welcome to Tech with SAS. In this video, we will talk about multi-master replication technique. If you have gone through my previous video, I have discussed about a single master replication technique. So in this video, the agenda will be first we'll cover the differences between single and multi-master, and then we'll see like what are the challenges which we face when we use the multi-master techniques, and then there'll be some techniques or some kind of ways by which we can overcome those challenges. So, without much ado, let us start. So, we can see that in a single master application, we have one node which acts as a master, and all the writes go through that only. So, and also it is responsible to propagate changes to other nodes, right? So, single master is very easy to implement, and also it is like highly consistent if we use the synchronous mode of single master. But a challenge is that there is an issue of performance, and some applications need performance more than consistency. For example, if you have an e-commerce application and you want to make sure that the cart of a customer is always like he can access that quickly, right? So even okay, if there is some issue of data consistency, that can be resolved at the payment page, right? So for those applications which has the preferences of higher performance and availability rather than consistency, so we use the multi-master application. So in multi-master, there is no one master, right? All the nodes can take up the write request, and they are responsible to make sure that other nodes are able to update that data, right? So what happens that in single master technique, we have one master that takes all writes and propagate response to other nodes and make sure that they are all sync. But in multi-master, every node is a master. They can take up the write request, but they have also have to make sure that that write which they are doing local must also reach to the other nodes, right? So also let us understand like what we have went to till now. So single master application, as I told, like it has like one master node, but multi-master doesn't have the one master. All nodes are like a master, and then the focus of single master application is the consistency. So it wants if we are using the synchronous mode of single master, then we are always consistent, right? So, but when we are focusing on performance and higher availability, we must go to the multi-master application. So now there is one challenge, right? When we use the multi-master application, so as there is no one single node that is keeping the order of request. So there might be chances that the request which come in in one by one, right? The data can be inconsistent between the nodes. So how do we resolve those conflict, right? Whenever one node, suppose one node is saying the value of variable x is 5, another is saying no, value is 7. So how do we resolve that? Okay, so these conflict all usually appears when we use the multi-master application technique, and there are a few ways by which we can overcome them. So first technique is that exposing console resolution to the client itself. So suppose you got like suppose for one node is saying the value of x is 10, another says is 5, then 15. Okay. So now you send back these values to the client itself and ask him or her that okay, what is the correct value? So suppose he says in this the value is 15. So you update that in all nodes. So like one way to resolve the conflict. Second way is like last write wins with latest timestamp. So suppose uh, we have like three writes happening like this, right? So here we can see that all three writes have a timestamp and X15 is the latest timestamp. So that wins because we are keeping track of timestamp, and so we will always take up the latest timestamp. But this not be a bulletproof mechanism because sometimes clocks are not synchronized or fine-tuned, and maybe data is not correct also when you are going with algorithms. Third one is the causality attacking algorithm. So system will use an algorithm that will keep track of a relationship between the different requests. So suppose there's a conflict of two writes. Suppose there are two writes A and B, and they're conflicting. So algorithm will try to check whether A is the cause of B or B is the cause of A. So, for example, here, suppose B is getting changed because of A. So we'll keep the B and discard the A. So these algorithm will keep track relationship between the request, and they will also try to fine tune, okay, which request is cause of another response or another write. So these algorithm can also be useful to resolve conflict in multi-master replication technique. So that's it for this video. Uh, Thank you very much for watching. See you next time. Please leave comments or questions if you have any, and please subscribe. Thanks all.